This is section 15.5, and we're really just focusing on finding the area between curves, and we did a little bit of that previously. And so you're going to be given two functions, and you'll graph that. Either you can sketch it, but most likely you'll be using your calculator, and either have to figure out the limits of integration or you're given that, and then we'll use our integral to find the area. So let's look at number one. Number one, you are given y is equal to 16x, and y is equal to x to the fifth. So here is x to the fifth, here is 16x, and we're talking about between x is 0 and x is 2. So those are our limits of integration. Let me grab my calculator. And so I went here and I put the two functions in my calculator. And then I've given you a window here that works because you couldn't see it if you just did a zoom 6. So I did change the y max to 30. I didn't change the x max, but we could. Let me just do that and see what that looks like. And then we'll hit graph. Well, that didn't work. Let's see what we're doing wrong. Okay, so I can't read my own writing, and I had x max is 5, and I put it in the x min. So back to the window. I put the x max to 5 and the y max to 30. And then when you graph it, you get a pretty good picture to sketch either on your paper and look at it so that you'll know what you're doing. And we're talking about the area between 0 and 2. So this area in here. And I don't need to use the calculator to find my intersection points because we know it's from 0 to 2. So the area is the integral from 0 to 2 of 16x minus x to the fifth. Why is 16x on top? Why is it first, subtracting the other one? Because it is essentially on the top of the shaded area. And so it's this function minus this one. So when you do the integral, it's 16x squared over 2 minus x to the sixth over 6 evaluated from 0 to 2, which means we plug in 2 and we plug in 0. We can see that when we plug in 0 for both of these, everything's going to go to 0. So I just have 8, because this is 16 divided by 2, so 8 times 2 squared minus 2 to the sixth over 6, and then I have a minus 0 for that function. So that's 32 minus 64 over 6. That ends up being 64 over 3, and that would be the area for that one, and they do want a fraction. All right, let's look at number 2. Number 2, you've got y is 2x plus 24, y is x squared. And so I've put a little 1 here so you could put that one in y1 and this one in y2 because we don't know the limits of integration. And I did give you a window for this one if you were practicing. So let's go to the calculator and see how we would do this one. So we'll go to y equals and we'll clear that out and we will put 2x plus 24. And we'll come down here and put x squared. We'll just do that. Whoops. I'm going to clear that and delete that. I'm just going to delete. So we have x squared. Okay, now I'm going to change the window based on what I've given you here. You could figure that out for yourself because you've got to see where you need to be, what you need to see when you're looking at it. If we just hit it now, let's see, let's do a zoom 6. That's what we would normally do. And we can't tell where anything hits. So you would have to figure out that you need a bigger y max and maybe more to the left, which would be your x min. So let's go in here and we'll put a negative 20 here. We'll leave 10 there. We'll leave negative 10 there, and we'll make 40 here. All right, so we'll hit graph. And now we can see the part that is going to be shaded. So that's that. We need to know this point and this point, what are those values? Because that's going to be our limits of integration. So we'll do second, calc, intersect, and hit enter 3 times. 1, 2, 3. We get this one is -4. When I'm going to find this one, I'll do second, calc, 5, but before I hit enter, I want to move to the right till I get close to that point. So now I can hit enter 3 times, and I get x is 6. So that's what you want to do. You want to graph it, find out where they intersect for that shaded region, and then that will be our limits of integration. So we have, and what's on top? What's on top is the line, this guy. So the area is the integral from -4 to 6 of 2x plus 24 minus x squared dx. And then you can use your Math 9. Let's see, let's go over here. And we'll put that there. And we will second quit out of this. And we'll go to, let me push that up here. All right, we'll go to Math and 9, which is the integral. And we'll put -4 here. And then we'll hit our arrow. And we'll put 6 there. And then we're going to put this whole line in that box. So that'll be 2x plus 24 minus x squared. And then we'll go out and put our x there. So we have just copied this into here. And remember, if you have the older calculator like an 83, you'll do Math 9, and then you will put the function, comma, x, comma, lower limit, upper limit. So that's what you do if you have an older. All right, we'll just hit enter. And we got this number. Let's change that to a fraction. Math and enter on fraction. And we get 500 over 3. Maybe they want a mixed number. If you divide 3 into that, you do get 166 2/3. I'm not sure what it's going to require on your actual homework question, but that is how we would do that. All right, that's number 2. Let's look at number 3. All right, so number 3, y equals x cubed minus 3x squared minus 27x plus 13, and y2 is x plus 13. So when you put those in your calculator, you get your cubic one and you get your straight line. Well, there's 2 regions. There's this yellow region, and then we have this blue region. And if you notice, for the yellow, the cubic thing is on top. For the blue, the line is on top. So that affects our integral. Use your calculator to find the numbers where this intersects, and you'd find -4 here, 0 here, 7 here. So now we've got 2 separate integrals. The yellow is from -4 to 0, cubic's on top. So we have the x cubed thing minus, put this in parentheses to keep the signs straight, minus x plus 3 dx. For the blue, we have the integral from 0 to 7 of the straight line minus, put parentheses, put the cubic thing, close, and dx. So you could do 2 Math 9s on that, and you get 2 different areas, and then you're going to add those together. And that would be your total area for the shaded region. So graph it, find the limits of integration, get your 2 integrals, knowing that in this one your cubic's on top, in this one the straight line's on top. So that affects what's first. All right. The last one, don't let the e to the x thing scare you. Y equals e to the x, and y equals -5x squared minus 6x. Same thing, you're going to put that in. That is this red graph. You'll put in the -5x squared, knowing that's a parabola, and it's going to be upside down. Do your window, whatever you need to do to see the intersection points. Find those. They're going to be decimal values. So this one is negative 1.144. This one's negative 0.164. And so what's on top? The parabola's on top. The area is the integral from negative this one to the other one of the parabola minus e to the x dx. And your area, you'll leave it in a decimal form for this question, is 0.827. There's just 4. We're just practicing that, finding the area. On the first one, I did it by hand as far as integration. You can totally use the Math 9 to get those. You still have to do some graphing. You still have to be able to write your integrals, find your intersecting points, but you can use your Math 9 to do your actual integration.